Good evening, my dear students. Today we can discuss the problems on mirror formula. What is the mirror formula? Mirror formula is one by V plus 1 by U equals to 1 by F. Here V equals to image distance. U equals to object distance. F equals to focal length. What is the image distance? The image distance is the distance from the pole of the mirror to the image. Next, what is the object distance? Object distance is the distance from the pole of the mirror to the object. What is the focal length? Focal length is the distance from the pole to the principal focus. Depending on this mirror formula, we can solve some problems. Another formula we will use is magnification. Magnification M equals to height of the image by height of the object equals to minus V by U. M is called magnification. Magnification. HI is size of the image. Size of the image. HO is the size of the object. Size of the object. We know V and U. V is the image distance, U is the object distance. So depending on this mirror formula, we can solve the two problems in this session. First one is example 9.1. Example 9.1, page number 144. So problem is, a convex mirror used for rear view on an automobile has a radius of curvature of 3 meter. If a bus is located at 5 meter from this mirror, find the position, nature and size of the image. Okay. Solution for this problem is, given mirror is convex mirror. Convex mirror. Convex mirror. Convex mirror. For that convex mirror, given data is, radius of the curvature is plus 3 meter. Plus 3 meter. See, for convex mirror, radius of curvature is positive. So, you know that R equals to 2F. So, focal length F equals to R by 2 equals to 3 by 2 meters. 3 by 2 meters. Next, if a bus is located at 5 meter, so U equals to object distance. Always object distance is negative from the sign conventions of the mirror. So, minus 5 meters. Minus 5 meters. So, now you have to find the position of the image. How can you find the position of the image? Position of the image can be found by using the mirror formula, that is 1 by F equals to 1 by V plus 1 by U. So, image position we can find by using the formula 1 by V equals to 1 by F minus 1 by U. So, 1 by F, that's equals to 1 by 3 by 2 minus 1 by U equals to minus 5. So, 2 by 3 plus 1 by 5. 2 by 3 plus 1 by 5. So, we have to find out the LCM for 3 and 5. you will get LCM is 15. So 3 5s are 15. So 5 into 2, 10 plus 5 into 3, 3. So 13 by 15 meter equals to 1 by V. So from this, V equals to 15 by 13 meter. So V equals to plus 13 1 ja 1. So 20. So 1 plus 70. So 5 meter plus 1.15 meter. So position of image is plus 1.15 meter from the pole of the mirror. Next, nature of the image you have to find. To find the nature of image, we have to find the magnification. Magnification M equals to height of the image by height of the object equals to minus V by U. So, minus of V. V, what is the value of the V? V equals to 15 by 13 meter. 15 by 13 meter. So, minus 15 by 13 meter by U value. U value is given, U value minus 5 meter. Minus 5 meter. So, you have to calculate minus 15 by 13 divided by minus 5 equals to minus will cancel. So 15 by 65. 15 by 65. So 5 3 ja 5 13. So this is magnification. So M equals to plus 3 by 13 equals to 0.2 and 0.23. 0.23 you will get. That is the magnification. So nature of the image you have to find out. Nature of the image is virtual, erect and diminished image. So what is the meaning of diminished? Diminished means height of the image is reduced by 0.23 times of the height of the object. So image size is diminished by 0.23 times of the size of the object. With this problem is completed. I am going for the next problem. Example 9.2, page number 144. Given problem is an object 4 centimeter in size is placed at 25 centimeter in front of a concave mirror of focal length 15 centimeter. At what distance from the mirror should a screen be placed in order to obtain a sharp image? Find the nature and the size of the image. So given object is 4 centimeter size. So HO equals to 4 centimeter. And object distance U equals to minus 25 centimeter. Focal length F equals to minus 15 centimeter. Why we have to take focal length F is minus 15 centimeter? Because from the sign conventions, focal length of the concave mirror is negative. So concave mirror focal length is negative. So now you have to find out the where screen should be placed in order to obtain a sharp image. So you have to find out the image distance. So you know the formula 1 by f equals to 1 by v plus 1 by u. Mirror formula you have to use. This is the mirror formula. Mirror formula. So 1 by v equals to 1 by f minus 1 by u. So what is the f? Focal length minus 15. So minus 1 by 15 minus 1 by u. So 1 by minus 25. That's equals to minus 1 by 15 plus 1 by 25 plus 1 by 25. So you have to find out the LCM for the 15 and 25. So 15, 25, you have to find the LCM. Both will divide by 5. 5 3 ja, 5 5 ja. So 5 into 3, 15 5, 75. So 75 is the LCM. So 15 5. So 15 5 is 75. So minus 5 plus 25 3 is 75. You will get the 3. So minus 2 by 75. So this is the 1 by v. So for cross multiplication, minus 2v equals to 75. So v equals to minus 75 by 2 equals to minus 2. Okay, minus 70 by 2 equals to 2 3 ja 37.5 centimeter, minus 37.5 centimeter. So image distance is minus 37.5 centimeter. Next, you have to find out the nature and the size of the image. So size of the image to find, we have to use the magnification. Height of the image by height of the image by height of the object equals to minus v by u. So you have to find out the height of the image. Height of the image equals to minus v by u into height of the object. So you have to find minus v. Minus v how much? Minus v equals to minus 37.5 by u is given. U is 25 centimeter into height of the object equals to 4. So you will get minus 6 centimeter, So height of the image equals to minus 6 centimeter. So minus 6 centimeter you got. So minus 6 centimeter means that image is enlarged. Okay. So image is real, inverted and enlarged. Image is real, inverted and enlarged. This is the answer for second problem. Next, in exercise, we can solve one more problem. The magnification produced by a plane mirror is +1. The magnification produced by a plane mirror is +1. What does this mean? we have to find out. Okay, magnification produced by a plane mirror. Solution for this problem is magnification. Magnification m equals to height of the image by height of the object equals to minus v by u equals to plus 1. So, from this data, first I can write height of the image by height of the object equals to plus 1. That means height of the image equals to height of the object. That means size of the image equals to size of the object. So when the plane mirror produces the image size is equal to the object size. So the size of the image, the size of the image is equal to the size of the object. Size of the object. Next, another one, minus v by u equals to plus 1. That means minus v equals to u. So modulus of v equals to modulus of u. What this indicates? The distance from the object, the distance of the object from the mirror is equal to the distance of the image from the mirror. So modulus of v equals to modulus vu means the distance of the object from the mirror is equal to the distance of the image from the mirror. So if magnification produced by a plane mirror is plus 1, that means the size of the image is equal to the size of the object. The distance of the object from the mirror is equal to the distance of the image from the mirror. So we conclude the two conclusions from this statement. When the plane mirror magnification is plus 1 means the size of the image is equal to the size of the object. The distance of the object from the mirror is equal to the distance of the image from the mirror. Okay. With this, today's session is completed. Tomorrow we can meet once again. Thank you for giving the opportunity.